Hello children, you're welcome to the mathematics segment of the program. It is mathematics time really, and that means it is time to have some fun. Hi, I'm Uncle Agbaje. Today in mathematics, we will be extending our knowledge of angles to angles in a triangle and related problems. But before we proceed into the topic, let us review the correction for the assignment that was given to you. I do hope that a lot of you were able to capture this screen. But if you did not, it's no problem. Let us take a look at the correction together. For this angle, taking the inner scale as our 0, we look at what the inner scale is saying on the other line, and that says 40 degrees. Even if we count 10, 20, 30, 40, so this angle is 40 degrees as has been indicated. Taking a look at this angle, still using the inner scale as our 0 point, we can count in tens until we get to the other line. Count with me. 10, 20, 30, 40, 50 right here. This has been obscured by the answer, so we'll take it again. From here to here is 10 degrees, 20, 30, 40, 50 here, 60, 70, 80, 90, 100, 110, 120, 130, and of course 140. So which means that from here to here, the angle is 140 degrees. Now for this one, perhaps a little bit tricky because it is not starting from 0. But like I taught you in the last class, we will take one of the lines as our 0 point. Let's use this one. Then we count in tens until we get to the other line. Let's go. From here to this place, 10, 20, 30, 40, 50. Now, if we count in 10 again, we'll go over to the other side, and that's 60. But we would have gone beyond the line. So we'll have to stop in the middle, and there is supposed to be 5 there. Let's take it again. From here to here is 10. Please do not count the 0 point. From here to here is 10, 20, 30, 40, 50. Then half of the remainder is 5. So 50 plus 5, that gives you 55 degrees. I hope that you got this. For those of you that attempted this, you deserve a cheer if you did get it right. Now we'll go on to today's lesson. Our objective for today is that by the end of the lesson, you should be able to identify different types of triangles based on their properties. You should also be able to calculate missing angles in a triangle. We'll just go straight to it. What do we mean by properties of a shape? The properties are what you can see or what you can observe directly. It does not mean what the shape has gone to buy in the market. So when we say properties of a triangle, for instance, let's talk about what you can see. An equilateral triangle is the first type of triangle. This is just a review of some of the things that you've been taught. So the first one we'll be reviewing is the equilateral triangle. It has 3 sides, of course, but the distinguishing feature, what is special about the equilateral triangle, is that all of its sides are of equal length. That is, side AC is the same thing as side AB, and that is the same thing as side BC. And there is a way we usually indicate this. We use single strokes to show that all the sides are equal. So when you see a shape and you see a stroke like this on one side and on another side, it means that the 2 sides are equal. In this case, the strokes are on the 3 sides. That means the 3 sides are equal. Sometimes it can be double strokes, as you will see in the next diagram. But for now, let's focus on this. It has 3 sides, and the 3 sides are equal. The reason why we call them equilateral triangle. Lateral is like saying the sides. Equilateral, equal sides. Always remember that. We can also call it an equiangular triangle because 3 angles are also equal. I mean, there are 3 sides, they are equal. There are 3 angles that are also equal. So A and B and C are equal. So you can call it an equiangular triangle as well. Now, we're going to be talking about sum of angles in a triangle at some point in the lesson. But for now, let us know that each of these angles is 60 degrees. So 60 degrees here, 60 degrees here, and 60 degrees here. I will explain why that is in the course of the lesson. You just pay attention to me. Now it has 3 lines of symmetry, as you may remember from your previous lessons. This means that we can fold the equilateral triangle into 2 equal parts, such that one part covers the other one exactly and nothing overlaps. So you can fold it from this way to the other side along this line. That is one line of symmetry. You can fold it along this way and along this line. That's another line of symmetry. And along this way from here to here, that's another line of symmetry. We'll talk more about triangles in subsequent lessons. Now this is the scalene triangle. The thing about the scalene triangle is that it's very easy to remember. None of its sides are equal and none of its angles are equal. That's just the scalene triangle for you. Very easy to remember. All the sides have different lengths. They are not equal to each other. I mean, this one is longer than, this one is longer than this, and this one is longer than this. And you can see by the markings that we have given to them, this one has 1 mark, and this one has 2 marks. That means they are not equal to each other. And this one has 3 marks. That means they are not equal to each other. So this is the scalene triangle. All the sides are of different length. All the angles are also of different lengths. That is, angle A is not equal to angle B. Angle B is not equal to angle C. So when you remember this, you have the scalene triangle. This one right here, if you remember from our last lesson, I said an angle that has a box in the corner is a right angle. So where you are able to form a triangle that has a right angle in there, you call this kind of triangle a right-angled triangle, simply because it has a right angle. So one of the angles is a right angle, as you can see, and I have told you that the value of the right angle is 90 degrees. Nobody will write that for you. They will just put a box in the corner for you to know. So whenever you see this box, always tell yourself that means 90 degrees. But of course, from our last lesson, you'll remember that this angle is less than 90. What do you think about this one? Is it less than 90 or greater than 90? Definitely less than 90. Good job, you. Now, the side that is opposite the right angle, that is, this is the right angle. Now, the side that is opposite, we'll call it the hypotenuse. From here to here, it is the longer side. The side facing the right angle is called the hypotenuse. So, but what you need to remember most is that it has a right angle, and that angle is 90 degrees. We will use that in the course of the lesson. Now to this special triangle. This is called an isosceles triangle. Now, what to remember about the isosceles triangle is that only 2 of its sides are equal. So we have had the possibilities. It's either 2 sides are equal, or 3 sides are equal, or no sides are equal. In this case, 2 sides are equal. Now, how do we know the 2 sides that are equal? The markings that I told you about earlier. Now, this one has double markings, and this one has double marking, and that means this and this are equal. But this one doesn't have any double marking, so this one is not equal to the 2 of them. Sometimes this one can have a single mark and a single mark, showing that they are equal, and this one will not have any mark. Wherever you see a triangle that has 2 sides marked, that means 2 sides are equal, and it is an isosceles triangle. It is a very special triangle. But beyond the fact that 2 sides are equal, 2 of the angles are also equal. But the question now is, which 2 angles are equal? It is very easy to know. When you see the 2 sides that are equal, trace both of them down, and you will see the 2 angles that are equal. I will take that again. To know the 2 angles that are equal, some people say it is the angle at the bottom. No, sometimes it may not be the angle at the bottom. Now, I will tell you how to get it again. When you see the 2 sides that are equal, trace them to where they end up in 2 different angles. These are the 2 angles that are equal. I will show you more of this in the examples that are to come. But it has just one line of symmetry, and that is you can only fold it once to be equal to each other. If you try to fold it from here to here, they won't be equal. Only if you fold from left to the right or right to the left along this line. But what is important is that 2 sides are equal, and 2 angles that are at the end of the lines are also equal. We move on. Now, a mathematical fact is the fact that all the angles in a triangle is 180 degrees. No matter how you draw the triangle, you are always going to add up all the angles, and they're always going to give you 180 degrees. But I'm going to prove this to you. I'm not just going to tell you to take my word for it. This is just an ordinary triangle. I want to show you that the angles inside the triangle will always give you 180 degrees. Now, the angles are A, B, and C. But what is A, B plus C? We don't know. but I want to show you that it is 180 degrees. I'm going to do that by bringing a line parallel to any of the sides. So let me take this line. And you remember that this mark means that they are parallel. Okay? Now I bring this line in just to show something. But now this angle and this angle, they form a Z. And if you may remember from your previous lessons, angles that form a Z are called alternate angles, and they are equal, which means that this angle forms a Z with this angle. So they are equal. And that means that if this is A, if the value of this one is A, then the value of this one will be A. Also, this one forms a Z with this one. And so that means if this one is C, this one will be C, because they are also alternate. So I'll take that again. This angle and this angle are equal because the form is Z, and alternate angles inside the Z are always equal. Also, this one forms an inverted Z, so this angle will be equal to this angle. But now something interesting has happened. I have three angles here, and it starts from here and ends here, and forms a straight line. Now, do you remember the straight line angle from the last lesson? What is the value of the straight line angle? Think and tell me. Now, the value of the straight line angle is 180. If you move from one place and you have not gone around the circle, you have only gone halfway, you will have gone 180 degrees, which means that if you take your distance A and your distance B and your distance C, everything must give you 180. A plus B plus C gives me 180. That means A plus B plus C must give me what? Of course, it's going to give you 180. So A plus B plus C is always going to give you 180. Any triangle that you have, whenever you add up all the angles inside, you will get 180. This is a very important point. Note it down. We're going to use it in the subsequent slides. Please, can they get it again so that they can note it down? Now we move on. Let's see how we can use this fact in worked example. Now this question says, find the missing angles in the diagram below. Find the missing angles in the diagram. And it gives me 50 as one of the angles. Then it says this one is X, and it says this one is Y. What am I going to do? I mean, come on, I have 50. The first thing I need to do is I need to work out a plan. Like I said, what do I want to find? And what I want to find is X and Y. But what do I know? I know that if I add all the three angles in a triangle, I will get 180 degrees. That means X plus Y plus 50 must give me 180 degrees. I know that one. What else do I know? Now, if I look at this, I want you to look at this triangle critically. What can you observe? Well, I will tell you what I can observe. And what I can observe is that there are markings. And Mr. Agbaji has told me that when you have markings like this, the two sides are equal. And when the two sides are equal, the angle at the end of the two sides are also equal. So now I also know that X and Y are the same thing. X is equal to Y. So what I'm going to do is that if I know that X is equal to Y, I can bring down one X instead of writing Y again. Since I know that Y is equal to X, I will also write X again for Y. I'll take that again. I know that X and Y are the same thing, so I write X. Now, this is Y. Instead of writing Y again to leave me confused, I will just write X since I know that they are the same thing. Whether you call him Taye or you call him Hassan. Taye and Hassan are the same thing. So, I put X. Now, this makes my work very easy. The next thing I'm going to do, this looks like an equation that we have done before in our first lesson. I'm just going to bring like terms together. Now, plus 50, remember, when it goes over the bridge, what does it become? Minus 50. So I bring all the numbers together and I leave the letters on this side. Now I merge terms. X plus X gives me 2X. 180 minus 50 gives me, 180 minus 50 gives me 130 degrees. So 2X gives me 130. What I'm saying is that 2 times something gives me 130. So what I do is I divide by 2. Remember from our first lesson, you divide by the coefficient of X. 2 cancels 2. 2 in 130. I would have loved for you to do that, but the answer has popped up on the screen. It's giving me 65. So 2 cancels 2, I'm left with X. 2 goes in 130 65 times. Now I know X. And if I know X, I also know Y. So X is 65, Y is 65, as you can see. But you can check, and I'll give you 15 seconds to do that. Check. 65, 65 plus 50. Is it going to give you 180? I'm sure you've checked that out. I'm sure that your answer is 180. So we'll circle the final answer. Good job, you. Let's see another example of a different nature. This one seems different. I mean, this is not an isosceles triangle, and nothing is marked. And it says, find the missing angles in this diagram. So what am I going to do? First thing, do not be scared of any mathematical problem. Always write out what you know. And what do we know? We know that if we add all the angles in a triangle, it's going to give us 180. So I'll write that A plus B plus 63. Everything must give me 180 degrees. Now, at this point, there is hardly anything I can do because I cannot add A and B. They are unlike terms that we have talked about. So I need to look again. What else do I know? And if I look deeper, I'm observing something here, but I'll give you 10 seconds to see if you can figure out something here. Well, I'm observing something here and I'll show you. This angle and this angle, they form a straight line. Two of them together, they form a straight line. That is, if I travel from here and I get to this place, it's a straight line. And all the angles on a straight line gives me what? Gives me 180. That means that the two of them must be 180 because they form a straight line. And I'll write that out. 110 degrees and B form 180. This is an equation that is easy for me to solve. I just move the number to the other side. So B is coming down. 110 as plus. When it moves over, it becomes minus 110. So I just merge this. 180 minus 110 degrees gives me 70 degrees. Now B is 70 degrees. Now that I know that B is 70, I can use this knowledge to finish up my abandoned project here. Okay, so now we're just going to go, I don't know A, so I'll bring A down. I know that B is 70, so instead of writing B, I write 70. Then I write 63. Now what I'm going to do is that I'm going to bring everything over to the other side. Or I can add them here and then bring them over to the other side. So that's what I'm going to do exactly. A comes down. 70 plus 63 gives us 133, which I'm going to take over to the other side. Plus 133 goes over to the other side and becomes minus 133. I have A left on this side. By the time I subtract this, what do I have? I have A to be 47. So now, I'm saying A is 47 and B is 70, and these are the angles that are required. I want you to try it. Add all the three angles and see if you're going to get 180. You have 10 seconds. I'm sure you got 180 degrees, so we'll conclude by saying A is 47 and B is 180 degrees. A final example, the problem says find the missing angles, and there are no numbers. This is looking very strange, but it's a very simple problem for a mathematician like you. I'll show you the way. What do we know? We know that this angle is 90 degrees. What else do we know? We know that these two sides are equal. And if these two sides are equal, these two angles are equal. And it has been written for us, F and F. Now I know that if I had all the angles in a triangle, I will get 90 degrees. I will just add them. F plus box, not plus box, plus 90 degrees. So F plus 90 degrees, everything must give me 180 degrees. Now bringing like terms together, F plus F will give me, I take plus 90 to the other side. Remember, it becomes minus 90 degrees. Now F plus F gives me 2F. 180 minus 90 gives me 90 degrees. Now divide by 2. If you divide by 2, you have 10 seconds. What do you get? I'm sure you're going to get F to be 45 degrees. This is our final answer. You can check it out by taking 45, F is 45, F is 45, and then adding it to 90. You will get 180 degrees. Now copy these questions and do them during your leisure. I will now hand you over to Uncle Popo for the General Studies lesson. Till I come your way next time, remain wonderful mathematicians.